last speaker for this conference is Geetali Thakur. She's not here, but she has sent her video. She's a university topper in chemical engineering with advanced diploma in industrial safety and MBA degree. And she's currently working for Cipla Limited as director and head for API and process safety. She is on board of reputed industry forums, including CII, Green Triangle Society, and Indian Chemical Council. Her topic is case studies, asset integrity, the bridge to achieve zero harm.
Hello, everyone. I'm Geetali Thakur, and it gives me really pleasure to connect to all the delegates around here in this INPSC International Process Safety Conference. And I also thank the INPSC organizers to have invited me for this particular talk on the process at the Process Safety Forum. Just giving a brief about myself, I'm responsible. I head the EHS for active pharmaceutical ingredients for Cipla Limited, and also I'm responsible globally for the process safety for Cipla Limited. So that's really a very short brief about me and in terms of my profile. And let's, without taking much of time, let me share my screen and right. So we are going to look at how asset integrity is a bridge towards the goal zero. Yeah, we all have a goal that's to have zero harm. Yeah, in the industry, all the EHS professionals, I guess that's something which is really on the top of the list in terms of a zero harm. And how asset integrity really helps to bring what is written in the documents and on the paper to achieve this zero harm goal. So before we go ahead, a disclaimer, two disclaimers, I should say. Yeah, one is that I'm not really somebody who designs asset integrity and would actually be implementing the asset integrity in terms of the mechanical design part of it. Yeah, so I'm more of a process safety professional who has carried out, who is very passionate about what do we really give to the shop floor. Yeah, so that's the first disclaimer. The second disclaimer, and please excuse me if possible, if at all I end up into that mode, is I'm sometimes a teacher rather than a speaker, and so I hopefully I wouldn't be into that mode today in the next few minutes. Right. So as we go ahead with this goal zero harm, yeah, what do we really look at is as process safety professionals like me, we would really put things into a particular, from a heads-up document, and then from this risk matrix, and then we would say this is something which is an unacceptable risk. This is something where we can bring in certain kind of controls. But what really can take us to to really where in fact a zero harm can be achieved is by working a lot on the part of asset integrity, of what is really required by the by to be safe by design. And what I mean by that is a lot of times when we do these risk assessments, we kind of assume certain things, right? And for example, we assume that the way in fact the nuts and bolts of a particular pipeline will be placed is going to be in the right position. Yeah, so asset integrity, just looking at the definition of it, will not go line by line into it, is to ensure that the important equipment actually, right, will be suitable for its intended application throughout its life cycle, whether it's been operated, the plant has been operated for 20 years, 30 years, whatever number of decades, it's going to be really, and to do what is to ensure that, we prevent the catastrophic failures during the operations. So that's really going to be our focus today when we talk about different case studies. Yeah, so I'm not just going to take you through a particular talk, but I'm going to take you through a few of case studies. Yeah, so again, coming back to this, so how do we look at this? Is the design, if you look at this, in fact, our good process engineers, then the process chemist, and then the R&D would give us certain kind of design integrity, right? And we try to really make a particular process safe by design. And then the operational integrity, that's nothing but the process safety management looks at what are the possible accidents. So if you see here, we have come up with some kind of a document. And now what's really important is to see how this particular things which are written till here in the document can really be made brought into a reality, yeah, to ensure that the asset performs well. And surely beyond that is to ensure how the particular asset that has been installed, yeah, is takes care of safer operations, that's minimum risk, and also ensures that overall equipment efficiency is as required or at its highest. We would look at, we would really get into each element of asset integrity. I'm sure I'm not going to bore you with talking about all this and giving you really lecture on this. Yeah, but we'll pick up some elements out of this and look at, we'll look at certain kind of case studies on how these particular elements actually can have impact on safe operations. Okay, we'll take some examples out of this. So risk assessment, so elements are right from risk assessment till, in fact, so the first part, if you see, is about the first 1, 2, 3, 4, actually is really about how do we get certain things installed right, and then is about how do we maintain them right, and then how do we really have that PDCA cycle of auditing and then ensuring the surveillance to ensure that, things are the way they are designed to be and the way they are desired to be. Okay. So let's move to our first case study. And I don't know if it's a good one to start with, but we are talking about toxic gas emissions, right? And the element that we have picked up is engineering design. And we'll look at how asset integrity does help in this particular case. So the case in this case, and let me again put up another disclaimer here, is these are not something which are incidents that have occurred, or in fact, these are not something. So this is not from any of the organizations that I've worked with, but surely something which are part and parcel of chemical industry. So not something specifically that I'm picking up. So the first case is of a particular reaction which has potential to form HCN gas as byproduct. Okay, and we all know that hydrogen cyanide is lethal. What is less known is it also has flash point as less as minus 17.8 degrees centigrade. So it's lethal as well as it can be flammable, right? So that's the case. And what is really required in this case, yeah, is by the engineering design is something what we can do is we could be having a nitrogen pressure padding here. We could ensure that the right scrubber design is put into place. Now, these are some things. The first two, if you see, is something that would get covered in process safety risk assessment studies, the operational integrity, that part that we mentioned about. But something that is really part of asset integrity is things like tongue and groove flanges. Yeah. So the engineer around there is going to be the one who would say that, for this kind of duty, right, we would have some specific type of flanges, some specific type of pipes, yeah, and what else could we be doing? Could we have minimum flanges, because those are the kind of the places from where emissions could be coming out, and also looking at how we could have our leak detection system, in fact leak detection and repair monitoring in place. So this is how, in fact, the asset integrity program could be really helping us around in this particular case. The next one is more interesting one. Yeah, let me actually promise you that we do have two more cases which are interesting. Yes, and if you see this, I think it's quite evident in terms of what you see in the picture. Yeah, short bolts. And I'm not sure about how much it is spoken about. But here we are talking about another asset integrity element, and that's construction and fabrication quality. Yeah, and this is something which can get, it could be overlooked during the engineering job or engineering installations. So in this particular case, the normal reaction liberates NOx gases. Okay, we do have such kind of reactions in chemical industry. The safety relief valve is designed for 2 kg per centimeter square. But the vapor column, the vapor column, which actually takes it to these NOx gases to a particular scrubber, is having short bolts. So you can imagine what can happen, right? And in this case, let's say that there is a scenario of vent blockage. So in that case, what's going to happen? Right? What could happen is that it would start pressurizing, and this could end up as a weak joint, leading to spraying of liquid from this flange joints, causing injury, disability, whatever we say. So just this particular small job, which we at times, end up these sometimes are in the hands of the contract employees who are carrying out this particular job. Imagine the consequence of this, and just a small thing of how the asset integrity has to be really plays a role. The third one is on corrosion register maintenance. So this is about corrosion maintenance is the third element that we have picked up here. And the cases, now, because this is a corrosive chemical or reaction mass, what is considered here is the Hastelloy reactor is used for reaction, followed by distillation. And so let's take a case where in fact the annual maintenance or in fact the regular maintenance is not done, or in fact it is rescheduled, or in fact because of production pressure, this has been, in fact, the production has been actually running for more number of months. And the kind of scenario or the hazard here is that the onset of decomposition of the distilled residue it lowers down if there is presence of iron. Okay, so if there is any amount of iron there, this is what can happen. So you can imagine that if this material of construction starts actually, if there is some pitting corrosion which is set in, then this could lead to onset of the decomposition lowering down, which means that the reaction mass residue which is there at the end of the distillation could be actually getting into decomposition mode at earlier temperatures than what it was actually supposed to be. And that can lead to overpressurization of this particular reactor, causing fatality, injury, whatever that we would say. Right? So I was just trying to link how important is it to is asset integrity right from the design stage till the maintenance stage, right? Design, fabrication, and then the maintenance stage. So in the given amount of time, I thought that these were three easier studies to put it across to the delegates at this particular conference. So just a closing remark I want to make is PHA has risk assessments, whatever we call it as, in whatever tool that we would do it, right? They are incomplete without a complete asset integrity program. And that's actually the reason why we actually require we require a good, strong asset integrity program. So with that, I would like to, I would really like to actually thank all the participants around here and actually end this particular short note on on this particular talk. Thank you very much. Thank you all.